Today is I'm going to go through the exam step by step and give you a chance to redo it. However, I completely changed my mind from now on. I'm not going to give you my Excel file, but you will have the videotape. But I really think that when I give you the Excel file, you kind of plug and play and get some false sense of security and say, oh, that's easy. But a lot of time, you know that the devil is in the detail. So I'll go through that step by step. And stop me anytime. Because I want you to not just watch the videotape and say, oh, he created A column, created a B column. You should be able to think it through step by step and said, oh, actually, we have everything since day one and just getting more and more complex. That's it, okay? And so stop me anytime you want. Yeah?
You want us to resubmit it?
Yeah, the TA will give you a chance to do the kind of like the previous exam. Okay. But the last time, we kind of just give you my Excel file and then, well, okay, sounds like nagging, but to me, there are three different levels of DOE. One is plug and play. A lot of University of Phoenix, they do that, right? You click, 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 you get the answer, that's it. The second one is you follow the spreadsheet and then create a spreadsheet yourself. And of course, the hardest level was the original plan, is you play with it and then you figure out the insight and then you can create whatever the monster you want to create, okay? But I still think we have 1 month, it's not too late. And the bottom line is, I don't want to fake it. I don't think you want to fake it. So we go through the whole thing step by step. Just, I'm not lying, you're not lying. You actually say, that's it. No big deal. Okay? That's the plan here, okay? Okay, so let's go through the problem. Yeah?
When is the redo going to be due?
TA decide. Because she's going to get extra grading to do. Okay? Okay, so let's do it step by step. First step, okay? Let me ask you this. We have 8 variables, right? A, B, C, D, E, F, G. So originally, if you just use A, B, C, D, E, F, G, plus, minus, all the way to plus, minus, you should have 256 observation. Everybody agree? Okay. Now, so if I have 258 observation, okay, originally, okay, this part, let's just say that we ignore it, okay? If I said that I'm going to use some high-level interactions, okay, I'm going to use some high-level interaction terms to break them into only 32 observations block. So totally is 2 to the 8, originally 256. And then we turn them into 2 to the A minus 3, 32. So we know that how many different ways we can block them? 8, right? So if you have 8 different ways you can block them, okay, and you pick the high level interaction, all I care about is this. I don't care you use A, B, C, D, B, C, D, E, whatever term you used, okay? If you use the high level interaction term to do it, when you're done, you separate them into 8 blocks. First thing first, Okay? If you didn't touch your A, B, C, D, E, okay, then the sum of every effect should be 0. Agree? That means that there are, they are orthogonal. No, there are contrast. Everybody agree? Second part, okay? Any two products, some products of any two of them, since they are positive, negative, orthogonal contrast. So no matter which of the 32 you used, the product should be 0. Agree? Everybody agree? So all I need you to show me is you can, build this and you can check, hey, see, pink block, yellow block, blue block, any one of the 8 blocks based on high-level interaction term, they are orthogonal contrast. Problem number 1. Everybody agree? And you don't really need to use all 8 of them. You just pick one of the 8, right? Okay, everybody show hands. So far, so good. Problem 1. Okay, now let's move to the next one. Okay, now suppose I use, this is not a way, okay, so next problem. Okay, first I'm going to solve the problem. This is your way, right?
You can open that answer 1, 2, 3 something like that.
Oh, okay. Oh, here we go. Okay, next. Suppose I copy one of the 8. Here's one of the 8 I copy. Okay? One of the 8 I copy. And then I'm let me do this first. Insert. Make it clear. Okay? Okay. One way you can create a data set, okay, is by saying that, let me make A a little higher, B a little higher, or in this example, you're doing what? B, C, and what's the other one you do? AC, okay. Now, suppose that I'm going to do AC, B, so basically I said that, okay, B I want a big, C I want a big, AC I want a big, and the rest, I don't care, but I want a small. Agree? So, can I have a set of observation and basically do this, okay? Oh, this is your original answer, or this is the Y, right? Y is over here, right?
Yes.
Okay, so now I'm just creating my Y value.
I guess they cannot see.
Oh, okay. So let me just create a Y value here for a second. Okay, so I can start by, let's just say that I don't want to get rid of everything for a second. Okay? Can I start from a central station that's all 100? Everybody is 100. Is that okay? And then I said, okay, I don't want to just central station 100, but then I want to have some value of B, the B effect is positive, right? So I want to have B effect, and the B effect could be plus 10 or minus 10, depends on the positive side or the negative side. So I can have the B effect. So I just say B effect, let me have 10. And then the B effect will be times either positive 1 or negative 1. So I'm going to lock my B effect. Okay? So I'm just locking my B effect. And so for the first one, now B is negative. Sorry. Should be here. Let me redo it. This equal to a central station 100. And let me just fake that 100 up here because that doesn't matter. Equal to 100 plus my B effect. B effect could be positive, could be negative. So it depends on it's positive or negative. So I'll have my B effect here. So people look at this. If I only have B effect, this will become what? 90, 110, 90, 110. Depends on B is positive or B is negative. Everybody with me? And next, I'll say that, what else you want? Remember, the problem, actually, I make it only 2 main effect and 1 interaction term, no matter which group you're in, right? So the other one is C effect. C effect, so I make a C effect. Okay? And then this time, also, times is positive 10 or negative 10. So this will be
your formula is a little wrong.
Yeah.
I think you accidentally pressed 4 instead of F4 right there.
Okay. F4. How's that?
That should have been.
Okay. So now we have B effect and C effect. So C the value become either if it's negative, negative is 70. Is positive, positive is 130. And so I have 4 different values. Depends on positive, negative. This wall, this wall, this wall, this wall. 4 wall. So far so good? Next. Okay? And of course, is 10, 20 good enough, big enough? That's the next problem. Because that depends on my local commute, the error term I give you. So if the error term I give you is 1,000, 10, 20 is not big enough. But if the error term I give you is, 25, 35, 10, 20 is still probably not good enough. And maybe needs 100, 200. You follow me? Okay, so next things, but let's just worry about one more term, is the interaction term, the AC term. So the AC term, I say, hey, let's use 25, okay? And I know that when TA give you the hint, told you can manipulate each one of them manually. And if you want to do that, sure, you still can do that. But here I'm just showing you this is the way how I would just not doing it manually, one by one, okay? So I have the AC interaction term. And of course, the AC, you know that is A times C, right? Right? So everybody with me? This is my Y effect was B effect, C effect, AC interactions, right? However, we need a local commute. Where the local commute coming from? I give it to you, right? So we add the randomness. Here is the randomness. So when you look at the randomness, okay, here's the tricks that relate to that problem. Is it big enough? Guess what I will do first? I will calculate the randomness average and standard deviation.
Could you move your screen over?
Oh, sure. One. Can you see it or not yet? Okay.
Yes.
Okay, so the standard deviation is this much. Okay? And of course, you need to do a QQ later for the residual, but now we don't care. We just say mean and standard deviation is about 25.5 for my randomness. Okay? So if my local commute, here, people look at it, is 25.5. So if I add the randomness plus the randomness into the observations, now I create my observation with too many, the B I said is there, C I said is there, and then the interaction term is there. Okay? Sure, you can do the sum of square and say that, hey, is it big enough? Do I have the effect? But what is your gut feeling here? Is the B effect, C effect big enough? Maybe, maybe not, right? And for me, what will be the easy, safe way out at the beginning is I probably will say that, man, your local commute, how big is it? 25 plus 5 or 10 is about 35 or about 40. So if your local commute can be as big as 40, I'm going to make every one of them at least 50. You follow me? So your local randomness is, plus minus, well, actually 25 plus 5 or minus 5 is that range. But if I make this 50 and make this, say, 60 and make this 55, okay? I can make the value, oscillate a little more. But people, watch here. What is the problem of this? Did you see that there are some negative values showing up? And why is that? Because I like my central station location at 100, right? And minus 50, minus 60, minus 55, I don't have enough central station for the below the central stations, one of them. So what to do? What to do? How about I start my average around 500? Then all the observation will be big enough to not worry about, have some negative. Well, computationally, if you're using sum of square, actually it's okay. But for exam or for a lot of stuff I'm doing, even I'm doing a real projects, I usually like to add a big number, so make sure that I can calculate everything from the positive side, easy to visualize. Okay, so before I go any further, anybody have questions about how to fake the data? You can manually do each one of them, but I can change this, say everybody is 55, 65, and then do the changes. How to generate a Y value? Everybody agree with me? Oh, and some of you said that,
That's a question.
some of you will say that, well, what about the not significant one? How about I add something in there? Sure, you can say that, oh, I would like to have a 0.2, 0.3 for the insignificant one. But for me, in the exam, guess what will be the best thing to do for those insignificant ones? Insignificant can be 0, right? Or 0.00001. Might as well just 0. Agree? You agree with me? I can have some effects so small I cannot see it. So might as well just let them be 0. And what's the beauty of this is that whatever I have right now is really due to what? Central station, B positive, B negative, C positive, C negative, AC positive, AC negative. End of the story. So far so good? Okay, Yami, what's up?
So those numbers that we're adding, 55, 65, those are just arbitrary to make those columns significant?
So I didn't make the problem that hard. What I'm saying is that once we do this, it's really follow your homework too, start doing this estimate, sum of square, all those computation, right? And when I do those computation, I can say that, okay, I want you to check the f-test value of the ANOVA table. I want the ANOVA table just pass, the p-value just pass 0.5, say 0.004999. And if you want to do that, that means what? When you fake the value here, you need to kind of drop it, drop until you violate, it's not significant anymore, and then just add a little bit, kind of like sandwich that until you barely hit the mark.
Okay.
But that will make the problem way too hard. And the way how I set it in the problem I frame is, hey, just make it big enough. So if you want to really make it big enough, you just make the value really, really large. That should stay away from that local commune range. You follow me?
Yeah, so those numbers are with
Yeah.
the sole purpose of skewing the data the way we want it.
Yes, yeah. Okay, I mean,
So why are we skewing the data?
what?
Why are we skewing the data? Because you told us that we shouldn't skew the data in class.
Yeah, of course.
So
But
why-
here, young man. Yeah, but let me ask you this, okay? You want to be the lawyer, right? One day. Agree? Okay, so someone want to fake the data and cheat and do everything to scam the system. You don't know how to detect the lie. Can you build a lie detector?
Okay, I just feel like that we weren't like.
So let me ask you this. So you only allow me to give you a data set, I build it, and then you test it. Then how did you know that I did not lie? The nature of this is a set of number, right?
Yeah, but then you do it with the QQ plot and the variability test.
Yeah, but those are testing the residual and saying that the procedure is legal. But the nature of the data, okay, two things. QQ plot tests the nature is what? The residual, whatever residual we have is normal, right? Or equal variance. Basically to test that our ANOVA table, the foundation of the ANOVA table is verifiable. Agree? Yeah. But on the other hand, how did you know this is real data or this is a fake data?
Well, I assume that they show the data they collected. You know? I assume like if I'm looking at the data, they show me the actual results from it.
Yeah, but-
I just have like some.
But so let me ask you this. Experimental, no. What I'm saying is that, so what's the foundation of experimental design?
Trying to find interaction between different variables.
Yeah, and so how did you know that so far, the ANOVA table, the sum of square, the entire techniques I give you is not a scam?
I mean, I'm paying for education, so I assume.
Well, you're paying for education, but because this could be a fake education, right?
Well,
Right?
if I'm paying like 10 grand a semester, I assume that the data you're doing is correct.
Okay, sure. But here, young man. So, how did you know what is true, what is not true? Based on trust or based on science? Based on verification, validation, and check? You want to know you can detect this whole thing by science, or you want to detect this whole thing because I say so?
I just feel like that you didn't tell us how to do this. Like, I feel like you were never taught like how to do this in class.
Class number 1, we build what? Central station, subway station and local commute, right? We have 16 number. Where are those 16 number coming from?
Observation, but no, you never told us like how typically we can use data.
Well, it's on the videotape. I fake the number. I say that here are central station, here are local station, and I even, put some random number in there to start with. Did I?
Okay, but that's like not the same concept. It's just like I was never shown. Okay, I guess like this, like that's not relatable because I was not.
So whatever I cover in lecture 1 got nothing to do with my lecture 10.
I'm not saying that. I'm just saying that the spectral design is a different kind of concept than a person.
Okay, then I'm guilty. I should always tell you, please go back, read lecture 1, lecture 2, lecture 3, until we can do lecture 10. I'm sorry. I'm guilty for that. Okay? Science is based on foundation, build it up, build it up, build it up. Okay? And here, I'm just saying that everybody agree this set of contrast is part of the 256 contrast. Everybody agrees. We did not touch this 5, but we used the interactions to build the A blocks. But when we build the A blocks, all the confounding are here, and all the main effects are on the other side. And for those values, okay, you can assign any value you want. And put it this way, I agree. Maybe I should say that here is the way to manipulate this. But can you manipulate a number 1 by 1 if you want to and say, oh, I have a big A effect, I have a big B effect, small b effect, I have a big C effect, small c effect, I have a big small AC effect. I never show you guys how to do that, but I did tell you that on that side of the wall, everything is smaller. On this side of the wall, everything is bigger, so there's a contrast between the two. Agreed?
Yeah.
Yeah, so are we doing anything deviate from that basic concept?
Well, we aren't, but it's just, I just feel like that wasn't like kind of, I just feel like it wasn't representative of what.
What you're saying is that I should talk about this same things in the lecture and test you the same thing in the exam and using the same spreadsheet I give you.
No, I'm saying that if you doesn't matter if it's like 8 by 3, if you just show us how to just like a 2 to the 3rd cube, and you just tell us like how to manipulate data using a 2 cubed one, and then I can take that same concept and apply it to a different one, like 8 minus 3 to 8 minus 4 to this 9 minus 5.
Okay, then let me ask you this. If that's the way the logic should go, tell me what should be done next. What is the logical exploration, expansion from where we are?
What do you mean?
Well, you already tell me what we have, then you tell me what we should go next.
For like the lecture, like the test?
You can go either way. You tell me what should be done next, because you obviously have very solid belief what experimental design should cover and should be tested. And of course, I also would argue this, okay? If anybody says that, hey, you should have given me the problem based on the spreadsheet you give me. I never give the spreadsheet before. This is a semester, because after COVID, people argue, and I said, okay, maybe I should let you try to have that. In the 30 years of my teaching in the past, before COVID, people always get tortured from the homework, repeat from the Excel, from the videotape. They need to build it up step by step. This is the first time I kind of like, hey, I'll let you guys play with my spreadsheet. But can I guarantee you will get a job? You'll work for a pharmaceutical company or work for an airline. They will always give you the same problem based on my spreadsheet, nothing else. You know, I will work for UPS, I will work for FedEx. They'll give me a data set. The data set will plug into the Excel I give you, and then you will get the answer. And a ANOVA table automatically p-value less than 0.05. If you believe that's the case in the future, I'll do it your way.
I guess I just think what Kelvin's trying to say, and what I was thinking about is, like, I generally understood what the problem was asking, but I kind of agree with him as, like, I didn't know exactly, like, I would not have ever guessed that this is specifically what you're looking for. Like, I'm looking at what's next to this as we go on,
Okay.
and I guess, like, I had something similar, like, I knew the general gist of, like,
Well, actually, if you get general using your manipulations, because sooner or later, would you agree with me that you just need to create a bunch of Y to do the your homework things,
Yeah.
right? This part we all agree, right? I'm just saying that if you do it manually, then you need to manually check. I got one Y too big, or one Y too big for this B, or one Y too small for that C, and then you need to do the adjustment very labor intensively. And that part I agree. But so okay, let me come back to this. Is this the correct answer or the perfect answer? No. I'm just saying that if I'm doing it, I want to get it done quick and dirty. Would you agree with me? Is this approach is more like, okay, here, big enough, not big enough, 55, 56, 57. I can kind of batch control the whole things until I get the answer. But if you don't do it that way, you do it this way, right? You can say that, my B effect or this term is too small, or this term is too big. Then you have to manually adjust each one of them at a time. And is that answer going to be wrong? I don't think so. It's just a lot more work. Because here, look at I'll tell you where is the tricks I play in the questions. The question I said is, please find the B effect, C effect, AC effect to be significant, big enough to be significant. But I also said that the rest to be insignificant, right? Right? That was the questions. So if you manipulate the value one by one, individually, is there a possibility that you make it, well, a little bit too big, a little bit too small, a little bit too big, a little bit too small, and then you're going to struggle for a while until you find a sum of square, those terms are big enough or small enough. Agree? So manual operations is not wrong. Just, only 32 number to worry. And if I make this problem like our exam 1, 16 value or 25 value, life will be easier. But 32, it's already pretty labor intensive. Imagine that I actually tell you that we're not doing 2 to the a minus 3, we do 2 to the a minus 2. That'll be 64. Or a minus 1, that'll be 128. That'll be even worse, right? So the question I ask you is that, make this big enough and the other small enough. Okay? The way how I did it here is I'm just trying to basically find a tuning device. You guys remember you take the machine learning, one machine learning homework is keep updating the value until you find the right parameter. You remember that homework? Okay. You actually can write a machine learning algorithm here and basically say, I don't know anything. Just keep updating the parameter until here. Okay. So the way how I did it here is here. You have the A effect, B effects. For this one, because we said that we have B, C, we copy. We need to do the sum of this part. I'm not gonna repeat. This part is exactly the same as your homework, right? Agree? So, and then I say you have to have your AC, and this I will say, please don't argue with me. I said it more than once. I said you have B effect, C effect, but you have AC interaction. But if you have AC interactions, C will be significant, but A is not significant. But legally, can you talk about AC interaction without discuss the A effect? So you have to bring the A effect up here. So once you bring the A effect up, so you use 4 degrees of freedom, and the rest is your error term. Agree? And the way actually I would do it is this. Okay. So again, I did not explain this like what Kevin said. I never explained this in the exam before the exam. But see if you agree with me. Whatever you put it in there, okay, as y, automatically you can, not yet. You can figure out the total sum of square automatically. Agree? And I think it's 31. Huh? Oh. The total variation is always the same, right? Huh? How come it's not the same?
I guess we left the last
Oh,
one.
oh, I missed one. Okay. Okay. So I always have I change the value, the total sum of square will change. Agree? Agree? 31 degrees of freedom, total sum of square, locked. When you change the value, it will change. So, for example, if I say this guy, I don't want to be 16, I want to be 17. The minute I change the value, the total sum of square will change. Agree? So here is my total sum of square. Okay? And then I also know that I have my model are based on how many things I put it in. This guy equal to this guy plus this guy plus this guy. Agree? Those are the 3 terms I said, hey, I worry about their contrast. So you know that what will be your sum of square error?
What's the difference between those two?
Yeah. So you just say that, okay, whatever your total minus those you're going to use for your model, that will be your error term. Okay? And then, of course, you know that this should be about 3 degrees of freedom. Well, if I don't talk about this A term. I'm just saying when I play with it. Okay? And then here should be 31 minus 3, 28 degrees of freedom. Okay? If I'm just play simple here. So can I have my MS bill? The MS should be what? This guy divided by this guy. And this guy divided by this guy. So far, so good? This is the ANOVA table you're supposed to have, right? And so your F value will be, F statistics will be what? Will be this guy divided by this guy. Oh, I need to have an F distribution, right? I'll have an F distribution. And then, I should have the degrees of freedom 3 and 28. What happened?
You need to tell the function if it's.
Oh, it's cumulative. Okay. Okay, so this is way too big. It's almost 1. But that's okay. Okay. All I want to do now is manipulate this, okay? I can say that make my or be, I can find a few terms. I say, oh, this is too small. I can make it 14 or 17. And then every time when I do that, I check my p-value. And this is, my p-value should be 1 minus this. It's really, really significant, okay? And when you do this, try this again and again. If I want to make this problem really, really hard, what should I do? Actually, this again is a legal argument. If I said legally, p-value less than 0.05 is significant, right? Okay? What kind of p-value will be the most sleazy, most dirty p-value?
0.
No, p-value should be 0.05 is good, right? So less than 0.05 is good. So I can have 0.4999999, right? That means what? It's really not legal, but I just make it barely legal. And that's really bad, right? And how to do that?
Well, you just manipulate the variables again.
And so I manipulate this to make these things drop, and 0.51, it's not good. Okay, 0.5, that's still not good. Let me drop a bit, so you can say 56, no good, 55.99, boom, I'm in. Okay? If you do it that way, it's almost like last time I talked about correlation coefficients. A lot of time, can I make something not correlated? Just add 1 or 2 big value, right? So can I do this the same way? All you need to do is this, okay? You find the maximum value or the minimum value of any one of them and said, okay, now I make this a little smaller. So you're basically manipulating this to have your significance done. Okay? Do you think that there's any dissertation, thesis, senior projects cheated this way? They done something, and then they said, uh-oh, we don't have significance. We really need a significance to graduate. And we just barely make this 65.1 or 65.01 until that thing's in. Is that doable? So now turn around. How to check that? How did you know someone is not cooking the data set?
Kind of wouldn't know.
Huh?
Wouldn't there be no way to find out? Because they could just argue that's the data we got. Because Because wouldn't you not have that number technically? That's like an arbitrary, like normally in the actual data you just have like observations.
That's why, first I'll agree with you. But that actually is the tragedy of today's so-called cloud computing, machine learning, data mining. There are a lot of scams on the e-business these days. So, I agree with you, right? But then, what is science? What is science really based on? Repeatability. So a lot of time, guess what people will do? I don't trust you, right? I'll find an independent source, repeat what you did. You said that if I have this, the COVID virus count will drop to certain level. Then we try to, you use hamster, I'll use the same hamster. You use pig, I'll use same pig. You did it on human, I'll did it on human. And then if, I repeat that, and sometimes even the law firm will do this. They'll find 2 or 3 universities did it independently. So nobody know who's doing this. Okay? And then when they come up with the whole things, you say your p-value is 0.0049. How come everybody try it as 0.7, 0.8? So in other words, is that the science is not repeatable. Then, that's... right now, what are the 3 major COVID vaccines? BNT, right? Pfizer, Moderna, and then the Europeans, Cambridge University's AZ, right? And do you think there are only 3 companies, or there are tons of other out there trying to dominate the market? There are a lot, and everybody said that I would like to have human trial. Everybody want to make money, and so, the only way to, what you said is true. If he cooked the number and he hide well, how can I know? I can't. The only way I can do it is give me your dosage. Let me find an independent source to repeat that. If I repeat 3 times, I don't get the same things you get, then I know something is fishy, right? So actually copy that down. One thing is called cohort. You guys know what cohort means? Yeah, it means that you try this on 85 years old female, I'll try it on 85 years old female. You try it on 220 pounds guys, I'll try it on 200. So we'll use the same group. Everything's the same, except, it's double-blinded. Anybody can explain what double-blinded also means for lie detection? You ever heard that double-blinded test for medicine? So the one receiving it, they could receive placebo, means fake medicine, or real medicine. And then the one provide the service, the clinicians, they could give you the real things or the fake things. But both sides, they only have a secret code. They don't know, except the independent analysis source, they know. Okay? So if you ask me that why this is important, well, let me put it this way. Do you guys think you're going to face more, scam or less scam in the future?
Probably more.
A lot more. You'll have medicine, you'll have electronic device, you'll have battery for car. Segway come up with a bike, okay? Promise 40 miles mileage for recharging. independent source triad, no more than 14 miles. Okay? And so, not only, this could get into an accident and for medical lawsuit or for consumer product lawsuit, but the opportunity for the future for this kind of detection is going to be more and more, because if you're the manufacturer, you need to prove that you're good, right? But if you're representing the consumer side, you want to double check, triple check, make sure it's good. Okay, so I think if you guys want to do here, there are a couple of things. First, let's go back one by one. For 256, the exam problem, you pick one of the sections to test that. Is that a problem?
So you don't need any of the other interactions when you're doing that first question, like A, B, A, C.
Because I already told you there's here. Let me. I'm not saying you're wrong. Okay, I'm just saying that let's follow your thought. Can I have E, F, G, H, I, J, K have few more terms?
No, I just mean like the ones you already have, like them interacting with each other.
You can have you can use A, B, you can use here I'm using B, C, D, E, H as the positive negative, right? But I can use A, B, C, D, E, F, G, H to be the one, right? Right?
Yeah. Okay.
Yeah, just pick three major interaction term. Okay. The things I did not ask you is technically you know that, like if you pick A, B, C, D and B, C, D, E, H, this two confound will cause the other confound. That will be still there. Okay. But for this problem, the focus is this. Okay. Whatever you do there, I'm trying to keep the discussion I want for main effect and two-way interaction not involved. So far, so good? Can everybody done this part and pick 32? No problem. Okay, second part. Okay. On this one, once you have this done, okay, you know you need BC term and AC interaction term, two main effect and one two-way interactions involved. Okay. You can do it this way. You said that, I still need to have a overall central station locations. Everybody agree you need a central station locations. And then you can do this manually and say that for all the B term is positive, I will have somewhere around 30, and all the way negative, I will say that drop 20. Positive, negative, you rather than using the parameter, say that they will be on this side or that side, you can manipulate them one by one manually. Agree? You follow me? Here I manipulate them in a batch. Agree? Here. 50. 65. If I do it this way, it means what? B is positive, increase 50. B is negative, drop 50. Agree? But can you do it manually and say that, when it's positive, I will add a little more. When it's negative, I'll drop a little more. And then just manipulate them one by one. That is also will reach the same set of number. Agree? Just one way is more work than the other. Okay? And okay, let me just ask you this. If I want to have C effects, D effects positive, and E effects positive, So I have 4 main effect, 1 two-way interaction. It will be a lot of work to do it manually now, right? Probably when you have so many main effect and two-way interaction, you want to do it in a batch way. Or cheat it in a batch way. So far, so good? But can anybody see that you can create a bunch of central station, subway station, and a bunch of local commute this way? Every y value is based on a bunch of central station and local station. Agree? And actually, I'll say this. Remember, I say this for the multiple comparison. I already said it before. I can have A positive, A negative, A negative, and B positive, B negative. So totally, how many subway stations I have? 4, right? A positive, A negative. So you can say that this I did it actually in the class. If I only have B and C, so let me just say B positive and C negative, without the AE interactions, I only have how many subway stations? 4, right? I will have B positive, C positive, yeah, just positive, positive. Positive, negative, and everybody agree with me that if I don't have the interaction term, I have only 4 subway stations. Positive, 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 negative, or those 4. And then you can do multiple comparison. Agree? If you want to test them just for those 4. And then what's next? I have the interaction term, right? So I already said it before. I can treat the interaction term as another positive and negative. So totally, if I really want to test how many subway stations in this example, BC and AC interactions for multiple comparison, Kevin, how many subway stations I have? Well, that's why I ask you, because okay, let me ask you one more time. If I only have B positive, B negative, C positive, C negative, I have 4 subway stations, right? Positive, 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 negative, 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 positive, right? Now I have BC, and then I have AC effects. So totally, if I want to lay them all out, how many subway stations I have? Hmm? 6?
Yeah.
Why 6?
Because you have up, down for each one, you have up, down for B, up, down for C, up, down for E.
Here, you agree with me? I have subway station, 4 of them so far, right? So can I have this 4 for AC positive? And this 4 for AC negative. So totally how many subway stations I'm going to end up if I want to do multiple comparison, lay them all out?
You have 2 different.
It's 8.
The 8, yeah.
Okay, so what I'm saying is if I treat it just with main station, subway station, ignore the regression and everything, okay? Is this too much different from our first example? It's look fancier, but it's really just 4 treatments become 8 treatments, right? And then I want you to compare the 8 treatments. Each treatment's got 4 observations. Now, are they big or are they small? And then I just want to make every group significantly different from the other groups. So here, once you create the value, okay, you can do this. This you can just copy paste from the Excel spreadsheet I give you. Agree? Because once you have 32, this is an example A6 or homework 7.3, right? Homework 7.3, you have exactly the same sum of square computation. Yeah?
So, as far as what makes this different than the homework,
Mm-hmm.
when you're doing the Excel and you're doing like the A, B, C, D, E, and like actually using like the Y values to calculate what they are.
Well, you still can do what I'm saying is you can do it the homework way, and it's still gonna give you a correct answer. The only thing I did here is kind of like trying to tell you that I'm not looking step by step. I'm kind of like step out and said that, hey, I manipulate and then I manipulate. That's it.
So just if you scroll back, so I understand that part, but if you're doing it like if you scroll up on the screen,
Okay.
and like when you're using those, when you're calculating out those values,
Oh, you mean the Y value?
like what is on the rest of the screen? How far do you go?
Oh,
As far as those combinations.
how many things you need to go?
Yes, that's
Ah, okay. Okay. Here.
because I couldn't figure that part out.
Here, let me ask you this. Originally, if I have 256, okay, and we can go through the laundry list. Okay, I'm with you. I will have A manufact, B manufact, C manufact, and all the way to whatever the A, B, C, D, E, F, G, right? And then I will have all the 2-way interaction term, and then I'll have all the 3-way interaction term, 4-way interaction term, who knows how many terms I have, right? But since we're trimming it down to just 32, so I only have 31 degrees of freedom. So when you have 31 degrees of freedom, remember here. Let me try this. Okay, say I have A effect calculated. Okay, but let's say that we're using A, B, C, D, and B, C, D, E, and E, F, G, H. Okay, as my positive negative separations. So if I'm using those as my separations, A effect is confounded with what effect? With ABCD will be confounded with BCD, right? Agree? And AC, BC, DE will be confounded with A, B, C, D, E, right? Agree? And this will be confounded with A, F, G, H, right? Well, you have to add, A, E, F, G, H. Okay? So, technically speaking, I need to figure out 255 minus the 31 I'm testing. a lot of confounding I need to think about, right? But what is the tricks I play here? Did I ask you what are the rest 31 you should have? You could have any two-way effect. You can have any three-way effect because you know that you just have them. Some of those things I don't care. Could be this, could be this, could be this, could be this, could be a possibility, right? One of the 8. But since I only care about I only care about B, C, and AC effect. I don't care about all the rest. Call them whatever. Does it really matter? You follow me? So when you generate the 31 here, okay, here. I know I care about this guy, right? B effect, I care, right? C effect, I care, right? AC interactions, I care, right? So I will say that they got to be B, they got to be C, they got to be AC. The rest, the 31 minus 3, the other 28, do I really care what you call them? And that's part of the reason I said that, hey, you see the dirty tricks I play here is I figure out a total, I figure out a 3 I care, and then I know that the rest, I'm just saying that, hey, lump them as an error term, I don't care. So if I don't care them, technically speaking, do I really need to calculate them one by one? Not really, right? But back to the courtroom things. In the court, they want to see everything's laid out. They don't want you to say that, oh, those things are lumped together, doesn't matter statistically. You follow me? Just like, remember, I said that we only care about B, C, AC significant. A not going to be significant, agree? But why I pull the A out? Because when you explain stuff, you cannot say, "Oh, I have this AC interactions," but you don't even know what's the A, what is C. Suddenly, you start talking about the AC interactions, then people will argue with you. So they're always this kind of like statistically, we're good, we manipulate, but at the same time, we need to do the other stuff. Okay. About a QQ plot, everybody knows how to do it, right? At least the homework already showed you. Just list them all out, or you need me to go through them.
The residual ones, maybe the QQ plot here, okay?
Okay, so,
How many times a day I don't think I would want to see it, like maybe at the beginning of this.
huh? The QQ?
Maybe just put it up on the screen and make sure it's what I'm thinking of.
Okay, you have the QQ?
Yes.
Okay,
Question number 9.
okay. So QQ step 1. This is the residual.
The next one is the residual plot.
Okay, so where is the residual? Why you only have this many value? Oh, here's the residual, but this is not the one of the leftover.
So there are 2 things, QQ plot.
Oh, here we go. So, but this is why this is not a residual, right? Or this is the residual.
So actually, I was referring some things online and there were 2 different things, but I guess they call QQ.
No. Just tell me what is this? Is this the residual or is this not? This is the residual.
Yes.
Okay, people, first you find your here. Let me create a couple more columns. Okay, so this is your error term. Okay, and where is your error? Or no, let's just say that your residual coming from. Okay, your residual is coming from what? From your y observation minus your beta 0 or your overall average minus the B effect and the C effect, you will have the leftover, right? So you know how to generate, everybody know how to generate the residual, agree? And once you generate the residual, next thing is what? Bubble sort them from the smallest to the largest. And once you bubble sort them, totally how many of them? 32 of them, right? And then you put the rank down from the smallest to the highest, 32. And then you treat them as a barcode, so every one minus half divided by the total 32. Then that will generate your probability value, the probability value. And then you plug them into normal inverse, that will give you their quantile value. So you plot them as really residual against your Q plot. And let me do it really quick. So here is your residual plot. Where is it? Yeah. But we're not plotting that guy. We're plotting the residual against your theoretical value. Okay? So your quantile say you're supposed to be here, but you're somewhere else. So these things, the correlation coefficient should be equal to what? The best. If this is perfectly normal. The correlation between the residual and your QQ and your Q value should be as close to 1 as possible, right? Agree? So if I calculate this, versus this, 0.96, and then you check with your table and said, oh, within the 95 percentile or 99 percentile. Okay, that's how you generate your QQ. Your residual should be normal. You know why? Because the random number I give you, guess how I generate a random number? I use normal distribution to generate it. You follow me? Huh?
The video is getting longer. It might.
What?
The video is getting longer. It might cause a problem.
Oh, okay. So, yeah, TA, let them redo this whole things, and I'm not gonna don't give them the spreadsheet. Let them redo the whole thing manually. Okay.